my name is Karen Alejandra Gamboa Lopez and I am going to present the part 1 of stage 3. First off, we have basic concepts of cinematic. So the first word that we need to know is mechanics. Mechanics can be divided into two ways. The first one is kinematics, which describes how objects move and studies types of motion. The other one is dynamics. The difference to kinematics describes why objects move and analyzes the causes of motion. So this is an easy theme to learn, so we're just moving forward to the next one. Distance versus displacement. First up, we need to know the distance is a scalar quantity. But what is exactly a scalar quantity? Okay, so according to internet, it's any quantity that only requires a magnitude or size to describe it completely. And a vectoral quantity, which is any quantity that needs to be fully described by identifying its magnitude and direction. So, scalar, we need magnitude, and vectoral, we need magnitude and direction. Okay? So, in this figure, we have the displacement and the distance. We can see that the displacement goes from point A to point B. It's a straight line from initial position to the final position. It's just a line. And the distance is the real length of the path followed. So it could be a very large line, but it will stop in the point B of the displacement. Okay, so it could be all your movement, it could be, like I said before, very large. It's just all the line that the object walks. It's example time. So, it says here, a cyclist travels around a circular track of 60 meters of diameter. Find distance and displacement if travels one lap. We first have to know how to obtain the perimeter of a circle. And we have that it's 2 by pi by radian. We have here diameter. But we just need the radius, so we just divide it by 2. 30 meters. So we have 30 meter is equal to 2 by pi by 30. We multiply 30 by 2 and we obtain 60 by pi. We obtain 60 by pi, which is the same to 60 by 3.14. We just answer it and we obtain that perimeter is equal to 188.4 meters to the square. So now we are just going to speed. So now we are just going with speed and velocity. Back to scalar and vectoral quantities. In this case, speed is a scalar quantity and velocity is a vectoral quantity. So, what's the difference between these two? We know that speed is how fast an object is moving, and velocity is the rate at which an object changes its position. Okay, so there's formulas to obtain about speed and velocity, and we have it here. Speed is equal to distance divided by time, and velocity is equal to displacement divided by time. So now it's again example time. Woo! Okay. It says here, a rabbit plays and moves as follows. First, he is moving 70 centimeters to the right, then 30 centimeters to the left. After that, 100 centimeters to the right, and finally 320 centimeters to the left. Okay, they ask us here, what was its total displacement? So, To obtain the total displacement, we just need to know from which point the rabbit moved. So to obtain the displacement, we need to know where is the point A to the point B, so we can calculate how many centimeters did the rabbit move. So it says here that first is moving 70 centimeters to the right, and then 30 centimeters to the left. We just raise 70 minus 30, we obtain 40 centimeters. Then it says that it moves 100 centimeters to the right. We just sum 100 plus 40, we obtain 140 centimeters. And finally, 320 centimeters to the left. We just raise 320 minus 140. We obtain 180 centimeters, but the answer is not complete. First, we have to know to which point did the rabbit move. To the right, to the left. In this case, the rabbit moved to the left, so the answer will be 180 centimeters to the left. Okay, the second question that it asks us is the time elapsed was 16 seconds. What was the rabbit's average speed? So, to calculate the speed, we already said that it's distance divided by time. So, this is the distance, but why? We have to sum every centimeter that the rabbit moved. Okay, so it will be 3 plus 70 plus 100 plus 320. The answer is 530. So we just put it on the formula, and it will be 530 divided by 16. Why 16? Because the question tells us that the time elapsed was 16 seconds. So the answer will be 32.5 centimeters per second. Don't forget that, because we have both distance and time. So now we are going to calculate the velocity. Remember that the formula is displacement divided by time. So we just already have the displacement, so we just replace it in the formula. We have 180 centimeters divided by 16. 16 because that was the information that the question gave us. So now we just divide it, and the answer is 11.25 centimeters per second to the left. Why to the left? Because that's why the displacement told us. So now we are going to talk about ULM, uniformly linear motion. There's some data that we need to learn before we do these exercises. So we have the variables. So we have the x that represents the distance and the displacement with meters. We have the v, which represents the speed and velocity, meters per second. And finally we have time, which is represented by seconds. Formulary is a small formula that it says that distance is equal to velocity per time. Example time. So, we have this question. Calculate the time in seconds that will take a train cover 3 kilometers in straight line to suit a velocity of 80 kilometers per hour. So this is an easy question because we don't have acceleration, so that means that we need to use ULM. And in these cases we have to use the tabla de tres simple. So we need to multiply 1 per 3 and divide the result by 80. So here it is, what we have to do. So here's the formula that we need to use. We have to eliminate hours, and multiply 80 by 3060 and 600. And the result is 135 seconds. That will be our velocity. So here is another theme, graphical analysis of ULN, which is the same as we already saw, but this time in graphics. We have the position time graphic. Is this? Here we have the position and here the time. Remember that the position is represented by meters and the time by seconds. And here we have a table that we will use. We have to remember that the slope is the same as velocity, so don't confuse. Here it is the formula to solve the slope. What does this represent? This represents the numbers that will be in this side, in the position side. And this will be the time. We are going to set it. It's sample time. So it says, a car travels with a constant velocity of 10 meters per second. So this is the table that we are going to use. It says, sketch a position time graphic. As already said, this is the position and this is the time. This is the table that we will use. So it's a constant velocity of 10 meters per second. So we do this. 10, 20, 30 and 40. Because that's what it moves every second. So now we pass it to the graphic. And we have 4 seconds. Now the position. We go with the numbers that are on this side of the graphic. And the velocity is the information that is on the problem. 10 meters per second. Now we are going to find the slope. Remember that this is the formula. So let's go back, and we will note that these are the y's and these are the x. So we can use any number of the graphic. For example, I will use 40 and 30, and I will use their counterparts of the time side. So it will be 3 and 4. We can put, 10 and 20 and 3 and 4 because the result will be wrong. So now, here I replace it 40 minus 30 and 4 minus 3. The result is 10 divided by 1 will be the same as 10 meters per second. That is the slope. So now we are going to sketch the velocity time graphic. So this will be because we know that the velocity is constant and it's 10 meters per second. So every second moves 10 meters. And here we have it. Okay, now for the last question, it says, find the area under the velocity versus time graphic. Okay, so here is what we have to do. And now we can select seconds and multiply 4 per 10 is equal to 40 meters. And that is our answer. Okay, so now that's all. Thank you for your attention.